Hi everyone. So the slide that I've got in front of you is ESRI form equals function, and I'm speaking really from a construction perspective. So I project managed the build of the ESRI, the Energy Safety Research Institute, and that was put forward as an initiative with regard to this goal. So ESRI, form equals function. It was a real drive and a target to create, design, and build a building that reflected the function of and the purpose of the building's use as well within it. So the institute specialises in the research of safe deployment of energy sources, research into safe extraction of energy, and also into renewable and green energies. So we were really keen to differentiate this building from anything else that we had at the university in our current estate, but also differentiate it from anything else in Wales. So we targeted BREEAM Outstanding, and this was to be the first BREEAM Outstanding educational building in Wales. So for us to achieve that, and we did achieve it, we achieved BREEAM Outstanding at design stage and then at post-construction review stage. Obviously, high environmental performance of the building was fundamental. And to do that, we did a three-stage approach, which was passive design to reduce the need for energy in the first place. We looked to maximize the energy efficiency of the building. We did this through use of A+ grade materials and processes, and then the use of renewables and low or zero carbon technologies. So the passive design was crucial with this building. What we tried to do is the strategy looked to halve the energy use of an equivalent mechanically ventilated building. So we looked at the services design in a lot of detail to try and achieve a passive design from a mechanical electrical perspective. And also the building's envelope was interrogated and designed to allow it to operate with a passive performance. So it subsequently included additional options to reduce energy consumption and to use and recover energy efficiently. So the building's orientation, layout, and ventilation were also key to achieving a passive design. And fundamental to this is quite a process-heavy building. So a lot of researchers occupying the building, a lot of research itself going on within the building. As you can see, one of the pictures on the slide shows one of our labs, which are traditionally energy hungry. So how could we offset that? So we offset it primarily with passive design. We utilized a passive ventilation system, which allowed us to cool the areas within the building using natural ventilation as opposed to mechanical, and also heat recovery to heat spaces that required heat in other times of the year. So we have a micro CHP unit. We have a large array of photovoltaics with operating on the building, which gives a strong yield there. And then we maximize the building's envelope in terms of U values and G values for the glazing. And that reduced the air permeability of the building down to the lowest possible target that we could achieve. So the way the building sort of works is we have displacement ventilation operates through the core of the building. We have air coming in through a passive venting system, and that goes stacked through the central core of the area. And by virtue of being the only higher education project in Wales to achieve this standard, the building reflects the commitment of the university to invest in the sustainability agenda, and has really raised the bar within our estate.
Yeah, good morning. So Borders College heat from sewage system. The college were looking to replace some of their older gas-fired plant back in 2016. So we're looking for an innovative product that we could retrofit at our campus in Galashiels. The Shark system came along, and it's the first of its kind within the UK. It effectively removes the heat from the passing sewer. The sewer passes the campus, and we divert the sewer into an underground tank, we then pump from there through the Shark heating system. The Shark system basically provides a mechanism to allow us to reduce the solids within the sewer, and it allows us to then pass that through a plate heat exchanger, where we have a viable operating clean water of about 15 to 20 degrees Celsius. That then gets passed through a set series of heat pumps, and then generates a clean heat source in the region of 55 to 60 degrees. It is then integrated into 5 different plant rooms in 3 different buildings across the campus, and it fits straight into the existing network with minimal intervention or modifications. So it also integrates with our BMS, integrates with our existing headers, our existing emitters, are all still in effect, and we also operate. We also have full control over the system through our BMS. It provides about 1.2 megawatts of heat, which is about 75% of the campus needs on an annual basis. Now, with this being slightly further north in Scotland, we do obviously have some challenging weather at times. Therefore, we always knew that we would have some form of requirement for gas. It has multiple applications. It has been retrofitted into various buildings of age and design, from new build, 1960s construction, Victorian mill buildings, etc. We're now looking at a phase 2, and a phase 2 is looking to use the distribution network to centralise our gas plant down to a single plant room, significantly reducing our requirement on about 13 boilers, and also the ongoing cost that the college would have in order to replace those. And when we'll use the heat network, the Shark heat network, to distribute that throughout the estate.
Okay, so ours took a holistic approach to try to bring together the estate side in terms of changing the infrastructure and how we improve our university campus, and tying that together with the action on the ground. So ours was called Light Solar Action, and it brought together the Energy and Carbon Lab, which comprised members of the project development team, our premises managers, energy manager, sustainability unit as a whole, and also the staff that work in our facilities help desk, to bring together all of those different aspects of managing the site and the knowledge that's gathered through each of those teams. So we work together then to kind of bring together improvements to the physical side and communicating those messages out. So for us all to be working towards the same goal rather than independently trying to do our own thing. So essentially we had 2 projects running simultaneously, which is the lights and the solar park. We secured funding from Salix to install LED lighting in a selection of 4 of our buildings. And at the same time, as that work was going on, installed solar panels on the same buildings. These buildings were selected because they were the newer builds. We'd already got teams working from our green impact side of programs to change their behaviours, and had been working on that for a number of years. So we'd already managed to cut their energy use before the LEDs and the solar went in. So we then have carried on rolling out the program of an LED replacement as part of our maintenance program. So working with the maintenance teams and the facilities help desk is looking at where there are other opportunities to roll that out as we carry on and refurb buildings. We improved our heating and cooling strategy so that staff know when the heating's coming on and when they can expect to have air conditioning provided, and have communicated that out through all of our green impact teams and induction programs. So since we've installed the solar panels about 2 or 3 years ago, we then rolled, just before the fits came in, increased that to 10 buildings across the university, and have generated 852.71 megawatts since then, which has resulted in 241 tonnes of carbon savings. And again, this has all been kind of communicated out through all of our communication side of things. So measuring and monitoring everything that we're doing and showcasing that, right, we've done our bit in terms of improving the university estate, but the other 60% of emission savings needs to come from action. And we've used programs like Green Impact and Do Nation to encourage our staff and students to get involved. So the key highlights there, we've managed to avoid, in terms of given that energy prices have gone up, we've managed to avoid spending 927,000 and actually achieved 74,000 savings on our previous energy consumption. And we've engaged students to get involved with their dissertation projects and have done kind of behaviour management projects as part of that.
So I'll start to introduce myself while this slide appears. As Rosie said, I work at the University of Nottingham, and my slide is the next one, please, Rosie. So I'm here to talk about something a little bit different from the other speakers, because I'm talking about one of our research projects as opposed to one of our build projects, and it's also related to homes as opposed to commercial buildings. So we always talking about reducing energy use, and we're talking about producing more at home, but actually going off grid for home is really, really difficult in the UK in particular, and elsewhere too. You need a lot of space, you need a lot of money, and you have a mismatch of when the generation and use happens. So you generate a lot in the day and use more at night. So how to overcome that? Well, we could start looking at battery storage, and I think that has been a lot in the news lately. And it seems a very attractive idea. However, it will take up quite a bit of space and quite a bit of your money. So what about a better idea? What about community energy? What about having a communal battery store and work with your neighbors? So when you have excess energy, you can lend it to your neighbors when your neighbor need the most, and when you need it again, you can borrow it back. So before you all go to the grid. So the whole idea here, the ethos here, is that we not only reduce the energy, so consume less, but we also share more, and therefore we make better use of energy generation on site and optimize the whole energy system. By doing that, we can then overcome the issue of the mismatch between generation and use. And we can, sorry, that's my timer to tell me at the end of my presentation. And that's what we do at Project Scene. So Project Scene is a project at the Trent Basin in Nottingham, a real-life community of low-energy homes, where we installed the largest community energy battery in the UK, and also thermal store. So the neighbors are connected, producing energy in their roofs, producing energy on their wasteland, in our solar farm, and then sharing and using for everybody and for the community.